In this section, we're going to talk about the surface area of pyramids and cones, and we have a whole bunch of vocabulary words to look at first before we do any examples, so let's get started. We're first going to talk about pyramids and all the parts of them, and then we're going to talk about how to find different kinds of areas, lateral and total surface area. So let's draw a picture of one and label some parts of it. Okay, so here is our picture of a pyramid. If you cannot draw this on your own, that's okay. Just do the best that you can. Let's go ahead and label some parts of this. So in all pyramids, there's one and only one vertex, and that's the very tip of it, okay? So this point right here, that's going to be our vertex. All right. Now, what lateral means, if you remember, lateral means the side. It's not any of the bases. So we also have lateral edges and lateral sides on this figure. A lateral edge is going to be, is going to be one of these pieces right here. So this is a lateral edge, okay? And there are several of them in this particular picture. And a lateral face is going to be an entire face of one of these sides. So we can make that be the front face, since that's the easiest one to see. So that could be this face right here. And I'm going to write face down here too, just in case. All right, so now we have a new kind of edge. This is called a base edge. Notice that in this pyramid, there's only one base. It's what the pyramid is sitting on. And there are edges that are going all around it. Well, these are called base edges. Okay? And once again, there are several of them in this entire picture. There's not just one. And then we have the entire base itself, which is going to be the very bottom part, what it's sitting on. So that's our base. And then the last part that we have is the altitude, or the height. And you want to be really careful about height with pyramids. A lot of people think that this edge, okay, in other words, a lateral edge represents height. That's incorrect. That's a lateral edge. It does not represent the height of anything. If you were meant to measure the height of yourself, you wouldn't measure yourself sideways. You'd measure yourself straight up and down. So that's going to connect the vertex directly to the base, and it's going to be in the center of the base, and that is going to be your height. And there's going to be a right angle down there too. So this is really, really important because a lot of kids make that mistake. The lateral edges are not the height, it's the altitude, it's the straight up and down part. Okay, so the slant height though, if you guys look at this front lateral, the lateral's face here in blue, that's the side that's facing us. If you can imagine, I'm going to do this the best I can, that there was a line right on top of that going right down the center of it that created a right angle. So this is not on the inside of this pyramid, it's on the outside. This would be called a slant height. So if you have a height and it's on a face, a lateral face, then it's called slant height. So there's a little difference there. But it's very important to know the difference, okay? Because when we go to find lateral area, we want the slant height. But when we want the volume or anything like that of this figure, we want to use the actual height in red. Alrighty, so let's talk about how to actually find area of these figures. We're going to write down some formulas. Okay, so for the lateral area, it's going to be equal to 1/2 times capital P, and capital P means perimeter of the base. And cursive L here stands for the slant height. So I'm going to go back over in my picture and I'm going to put a little cursive L next to that slant height just so that I remember that that's what that is. Okay. And if you're overwhelmed by all this information, it's okay. This is brand new information. I will show you examples as to how to find these areas. The next kind of area that we're going to look at is the total area. And of course, by that I mean the total surface area. So we still have that 1/2 times P times L, because that was the lateral part. And then this capital B stands for the area of the base. So I'm going to add up all of my areas together to give me the surface area. All right, a lot of information. Let's take a look at an example to see how to use this. All right, so here's our example. We're going to find the lateral and total surface area of this pyramid. So if you can see in this picture, this 9 inches in red, that represents my slant height. And I know that because it's lying alongside of a face. So that's going to be my cursive L in my formula. Okay. I also know that one piece of this base is 6 inches, and all bases of pyramids are regular figures, so all of these sides are going to be 6 inches. Okay. So that's going to be helpful because that's going to help us solve for the capital P in our formula. And this blue part, this is lying on the base, okay? It's on the very bottom of the figure. And this is in apothem, that 3 square roots of 3. And the way that I know that is because it connects the center of that figure to a side at a right angle. And that's going to be helpful in us finding the area of that base. So let's go ahead and write the formula down again. Okay, so we want to go ahead and start substituting what we can. So 1/2 times the perimeter, I'm going to go and find that in just a second, times the slant height. Well, I already know that the slant height is 9, so I'm going to go ahead and plug that in. The perimeter, let's see, I've got 6 inches times 1, 2, 3, 4, 5, 6. So 6 times 6 is 36. So I'm going to put that here. Okay, so I'm going to go through the process of solving. So half of 36 is 18, and 18 times 9 is 162 square inches. So that's my lateral area. So when we go in to find the total surface area, I can use that 162 to help me out, because now I just have to find the area of that base. So I'm going to substitute 162 for this piece right here, because that's what I just solved it for. All right, so now comes the area of the base part. So the area of a regular polygon, if you remember, is 1/2 times the apothem times the perimeter of the figure. So the 1/2 isn't going to change. My apothem is 3 square roots of 3. And the perimeter of the base, well, we already found that out, that's 36. So I'm going to go ahead and type this in my calculator, and I'm going to see what I get. And I get about 93.531. And remember, I want you to keep 3 decimal places if you can. So I'm going to add those up together, and I'm going to have 255.531 inches squared, or square inches. So that's how we're going to do that with pyramids. All right, last one, let's take a look at cones. All right, so we're going to start by drawing a picture and labeling all the parts that we know the vocabulary. All right, so here's a picture of a cone, just like an ice cream cone, but upside down. And we still have what's called slant height, and that's just going to be the length of the side, okay, that holds the ice cream. So I'm just going to label that as cursive L now that we know that represents slant height. And the actual height, remember, is the altitude part, which connects the vertex to the center of the base at a right angle. And all of the bases for cones are going to be circles. Okay. And then, of course, the part that's lying flat on the surface is the base. All right. And that's all the vocabulary that we really need for this. If the height, if the red part lies outside of your cone, it can kind of be a little tricky to see. Let me show you a quick example. Let's say this was my cone and it wanted the height. It would still be from the vertex straight down. So it may not actually connect to the center of this particular kind of cone, but it's still the height that you want. Okay? All right, so in order to find the lateral surface area, you can do one of two things. You can either do pi RL or 1/2 times 2 pi r times L. And the difference is, these are the exact same thing. This one here has just been simplified. And that's what I'm going to use too. So let's go ahead and fill in some information in this picture and find the lateral surface area. All right, so I'm going to do pi RL, and the radius now in this figure, I just added it in, is going to be in orange, and that's going to be 5. And then the slant height is going to be 8. So now it's just a process of multiplying, and we can leave this in terms of pi, especially because we don't have to round that way, so it's more accurate. So 5 times 8 is 40, so then just 40 pi, and I'll just write units squared, since there are no units. And then the surface area of the total figure is going to be that lateral surface area plus the area of the base, which is a circle, so pi r squared is the area of the base. Now I already found out the lateral surface area, so I'm just going to replace this part with 40 pi. And I'm going to go ahead and find out what pi r squared is. So I'm going to square the radius, which is 5 times 5, so that's 25, and then add on a pi. So 40 pi's plus 25 pi's, 65 pi units squared. Just like that. And that concludes this tutorial.